Hello everyone, welcome back to Anonymous World. Hope you all are doing well. I was inactive a bit due to my college exam and projects, but I am back and I will be continuing my compromising Active Directory series of TryHackMe, and today we will be solving fourth room of the series. So let's get started. So let's start lateral movement and pivoting. First introduction. So in this room, we will look at lateral movement and a group of technique used by attackers to move around the network, also while creating as few alerts as possible. So we must not be much noisy, otherwise we would get detected easily. So it is recommended to go through the breaching AD and enumerating AD rooms before this one. Okay. Objectives of today's room: familiarize yourself with the lateral movement techniques used by attackers, learning how to use alternative authentication material to move laterally, and also learning different methods to use compromised hosts as pivots. Okay, so first, how to connect to the network. If you are using a tag box, you will be connected to network automatically if you start the tag box from the rooms page, and you can verify this by running ping commands against the IP, and also you need to configure DNS, and we can test the DNS by running nslookup thmdc.za.trackme.com. Okay, so you should also take time to make note of your VPN IP using ipconfig or IPA, and the adapter name is lateral movement. So other hosts, if you are going to use your own attack machine, and OpenVPN configuration file have been generated. So go to your access page, select lateral movement and pivoting from the VPN servers, and download the configuration file. Okay, so let's download our configuration file. Networks, lateral movement and pivot. Wait. Now connect to it using OpenVPN, and the normal initialization sequence completed tells that we are connected. And then finally we need to edit the DNS manager. But IP we need to add 10.200.78.101. Okay, so now we will edit the DNS settings. So advanced network configuration, wide connection settings, IPv4 settings, and add the new one, 78.101. Great. So now I think we need to restart our network manager. Great. Now when configuring DNS in this way, the nslookup won't work as expected. To test if you configure your DNS directly correctly, just navigate to, if you see the website, you are set up for the restroom. Okay, let's see. Okay, we can have access here. Username Suzanne Morris, password is password. Wait. Now requesting your credentials. Okay, I think we have already done that step. So the credential pair will provide you SSH access to THM-ZMP2. It can be seen as jump host into this environment, simulating a foothold that you have achieved. Okay. Note on reverse shells: if you're using the tag box and have joined the other network room before, be sure to select IP address assigned to the terminal interface facing lateral movement and pivoting. Okay, so let's move forward. So now moving through the network, what is lateral movement? If we say in simple word, it is the group of techniques which are used by attackers to move around a network. So once an attacker has gained access to the first machine of the network, moving is essential for many reasons, including the following: reaching our goals as attacker, bypassing network connection, establishing additional points of entry, creating confusion and avoid detection. So several cyber kill chains reference lateral movement as additional step on a linear process, but it is actually a part of cycle. During this cycle, we use any available credential to perform lateral movement. So initial recon is done, then initial compromise, then the foothold is established, then we try to escalate privileges, and then there is a cycle where we do again perform internal recon, then move laterally, maintain persistence, then again try to escalate privileges, then from that elevated ID we try to again do recon, and it goes on until the final goal is achieved. So a quick example is given here. I think you can go through that. So from attacker's perspective, there are several ways in which an attacker can move laterally. And the simplest way would be to use standard administrative protocols like WinRM, RDP, VNC, or SSH to connect to other machines around the network. So this approach can be used to emulate regular users' behavior and somewhat as long as some coherence is maintained when planning where to connect with what account. Okay. So while a user from IT connecting to web server by RDP might be useful and go under the radar, care must be taken not to attempt suspicious connections. For example, why is a local admin user connecting to this particular PC from that marketing PC? Okay, administrators and UAC, while performing most of the lateral movement techniques introduced throughout the room, we will mainly use administrator credentials. While one might expect that every single administrator account would serve the same purpose, a distinction has to be made between two types of administrators. Okay, so first administrator, local accounts part of the local administrator group, and the domain accounts which are part of the local administrator group. So the main difference we are interested in are restrictions imposed by user access control or UAC over local administrator. By default, local administrator won't be able to remotely connect to a machine and perform administrative tasks unless using an interactive session through RDP. Windows will deny any administrative task requested via RPC, SMB, or WinRM, since such administrators will be logged in with a filtered medium integrity token that prevents the account from doing certain privileged actions. Okay, so let's go to task spawning process remotely. So the task tree will look at available methods, and attacker has to spawn a process remotely, allowing them to run commands on machine where they have valid credentials. Okay, so each technique uses slightly different ways to achieve the same purpose, and some of them might be better fit for specific scenarios. So first one is PSXX. So ports 445 TCP SMB is used. Required group membership administrators. It has been the go-to method when needing to execute processes remotely for years. Okay, the way it works is first connect to admin computer and share and upload a service binary. PSEXIS uses psxxvc.exe as the name. Connect to the service control manager to create and run a service associated with the service binary. Now, and third step would be to create some named pipes to handle standard input, standard output, and error. So we only need to supply the required administrator credentials for the remote host, and the command we want to run is available under C tools in THA JMP2 for our convenience. So the first step is uploading service executable to admin share, then creating and executing service. And the third step is communication through pipe PSEXE SVC. I don't know how to pronounce that. Okay, so remote process creation using WinRM. So it uses port 5985 WinRM HTTP or 5986 WinRM HTTPS. So it requires group membership, remote management users. So WinRM is a web-based protocol used to send PowerShell commands to Windows hosts remotely. And most Windows Server installation will have WinRM enabled by default. So to connect to a remote PowerShell session from the command line, we can use the following command: winrs.exe, then -u, it's for user, then p for password, and r for target, and then cmd. We can achieve the same from PowerShell, but to pass different credentials, we will need to create a PS credential object. After creating the object, we can create interactive session using the enter PS session command. And PowerShell also includes invoke command cmdlet, which runs script blocks remotely via WinRM. So credential must be passed through a PS credential object as well. And then the third method is creating services using SC. It uses multiple ports 113, 445, and 139, and also require group memberships of administrators. Okay, so we can create a service on a remote host with sc.exe, a standard tool which is available in Windows. When using SC, it will try to connect to the service control manager remote service program through RPC in several ways. So first, a connection attempt will be made using DCE RPC. Here, the client will first try to connect to endpoint manager, endpoint mapper at port 135 that serves as a catalog of available RPC endpoints, and then endpoint mapper will then respond with the IP and port to connect to SVCCTL, which is Service Control Manager. Okay, so if the connection it fails, SC will try to reach SVCTL through SMB named pipes either on port 445 or 139. And we can create and start service name THM service using the following command. Okay, the net user command will be executed when the service is started, creating a new local user on the system. To stop and delete the service, we can then execute the following commands. Okay, so creating scheduled tasks remotely, we use ch tasks. Okay, you can go through that. So let's get to work. To complete this exercise, you will need to connect to THMJMP2 using the credential which we received from task 1, these credentials. Okay, so let's connect via SSH to change the username for something Morris, I guess. Okay, Suzanne.Morris and password. Okay, so we are connected. For this exercise, we will assume we already have captured some credentials with administrative access. Okay, Leonard Summers is at pass forever. So we will see how to use these credentials to move laterally to THMISS using SC.txt. And we can also try other methods as they all should work against this particular. So while we already shown how to use SC to create a user on remote system, we can also upload any binary we would like to execute and associate with the creator service. Okay, so we will be using MSFNM to create a reverse shell. Okay, let's do that. First, let's check our IP. For lateral movement, it's 10.15.77148. Okay, 10.50.77148. Okay, so it will create a reverse shell. Let's see what to do. So we will then proceed to use T1 underscore Leonard or Summers credential to upload our payload on the admin share of the THMIS using sub SMB client from our attack box. Okay, it's done now. Now let's upload it using SMB client. Password for Leonard Summers. Okay, so it's done. Once our executable is uploaded, we can set up a listener on attacker's machine, on our machine, to receive the reverse shell from MSF console. Okay, let's do that. Console. So we will be using exploit multi-handler and we will set our payload to Windows shell reverse TCP. Okay, show options. So we need to set our L host and L port. L port is already set. 10.50.7.148. Okay, and we need to set payload. What was it? Windows shell reverse TCP. Okay, the value is specified for payload is not valid. Okay, what was I doing? Okay, there was a typo in because let's exploit this. Okay, so started reverse TCP handler. Let's go ahead. So alternatively, you can also use a one-liner. So we'll skip that. Since sc.exe doesn't allow us to specify credential as part of the command, we need to use run as to spawn a new shell with even Leonard Summers access token. Still, we only have SSH access to machine. So if you tried something like run as net only user, the new command prompt would spawn on the user session, but we would have no access to it. So to overcome this problem, we can use run as to spawn a second reverse shell with Leonard Summer access token. So we can use this command. No, there is a note. Remember that since we are using run as with the net only option, it will not bother to check if the provided credentials are valid. So we saw more about this on inheriting AD room. So be sure to type the password correctly. Okay, so we need to execute it here. Dot 50 dot 77.148. Is there a issue in command? Okay, that is correct. Now let's start one listener. Okay, password. It was EZ for something. Make sure to type the correct password. Attempting to start. Okay, there was no access denied. Let's see. Yeah, we got shell demise. Zen Morris. Okay, and finally, proceed to create a new service remotely by using SC associated with our uploaded binary. So now we can use this. Be sure to change the name of your service to avoid clashing with other students. Okay, let's change it right now. 3269. Okay, we will need to change here also. Okay, forgot copying. Yeah, sorry. Okay, let's see. Yeah, we are getting something here, and we got a virtual here too. Anti-authority system. So after running the flag exe file on T1 Leonard Summers desktop on THMISS, what is the flag? Okay, let's see. Users, okay, or T1 Leonard dot Summers. We need to go to desktop. Okay, we need to run free. Sorry, flag.exe. And game, what's happening? Yeah, finally, THM moving with success. So many typos. Now, moving to next task, moving laterally using WMI, Windows Management Instrumentation. Okay, so it is Windows implementation of web-based enterprise management, and which is an enterprise standard for accessing management information across all the devices. So in layman terms, it allows administrator to perform standard management tasks that attackers can abuse to perform lateral movement in various ways. So first is connecting to WMI from PowerShell. So before being able to connect to WMI or Windows Management Instrumentation using PowerShell commands, we will require to create PS credential object with our user and password. Okay, so this object will be stored in the credential variable and utilized throughout the techniques on this task. So further, we will proceed to establish a session using either of the following protocols. First one is DCOM and the second one is WSMAN. To establish a WMI session from PowerShell, you can use the following commands and store the session on session variable. Okay. Remote access process creation using WMI, it requires it uses port 135, 4152, or 135 and ports between 4152 to 65535, and also 5985 and 5986 according to HTTP or HTTPS. And group membership required is of administrator. So we can remotely spawn a process from PowerShell by leveraging WMI, sending a WMI request to Win32 process to spawn the process under the session we created before. Okay. On legacy system, the same can be done using WMIC.exe. Okay. So creating services remotely with WMI. It also uses same ports and group membership. Okay, for the following command can be used to create a service. So first invoke a sim method and the session variable is there. We need to initialize name, display name, the path name, service type, and the start name, and it can be all stored as service. Finally, we can stop and delete service with the following commands: creating scheduled tasks remotely. Then we can do installing MSI package through WMI. So let's see what we need to do here. So to complete this exercise, we need to connect to THM shared MP2 using the credential. Okay. For this exercise, we assume we have already captured some credentials with administrative access. So we'll show how to use this credential to move laterally to THM-IS using WMI and MSI packages. And again, we are free to try another method. So first, we will be creating an MSI payload with MSFNM from our attacker machine. So since we'll be sharing the lab with others, we will want to use different file names for our payload instead of my installer.msi to avoid overwriting someone else's payload. Okay, fair. Let's create a new payload. What should we name this? Let's keep this my payload. And then we then copy the payload using SNB or any other method available. Okay. We need to change the file name. My payload. Password is putting file in case was successful. Now it will be available at C Windows on the server, so we can start a handler to receive the reverse shell from Metas. In here also we can use one-liner if you wish. If we will again use set MS to lateral movement, or you can give your IP to output what port did we give to the profile. Okay, then our payload, and we can. So now let's start a WMI session against THMISS from PowerShell console. Let's try that again. So it's fine this time. So we then invoke the install method from the Win32 class to trigger the payload. First, let's change the file name. payload. So we received the reversal connection in the authority system. Great. So after running the flag exe file, T1 call new address. Okay. Cannot find and flag.exe. Perfect. Not happy. Moving with WMI profile. Now, use of alternate authentication material. That's material, right? So, what do we mean by alternate authentication material? So, it refers to any piece of data that can be used to access a Windows account without actually knowing a user's password itself. So, how is this possible? It is possible because of how some authentication protocol used by Windows network work. So in this task, we'll take a look at a couple of alternatives available to log as a user when either the following authentication protocol is used. So mainly two authentication protocols are used, MT11 and Kerberos. So during this task, we are assumed to be familiar with the methods and tool to extract credentials from a host. So Mimikatz will be using Mimikatz as a tool of choice for credential extraction throughout the tool. So before diving into the actual lateral techniques, let's take a look at how Ethereum authentication works. So we've already covered that previously. So first, a client sends an authentication request, and in return the server sends a challenge, and then the client uses NTLM hash plus challenge, which gives a response. Then again, client sends this to server. Then server sends that challenge response to domain controller. Then it matches with the response stored in that in database. Then it sends a response accordingly, either allowed or denied. And then server then transfer that allow deny authentication to client. Okay. So first method is pass the hash. So as a result of extracting credential from a host where we have attained administrative privileges, we might get clear text password or hashes that will be easily cracked. However, if we aren't lucky enough, we will end up with a non-cracked NTLM password hashes. So it may seem we can't really use those hashes. The NTLM challenge sent during authentication can be responded to just by knowing the password hash. So what it means, we can authenticate without requiring the plain text password to be known. Instead of having a crack NTLM hash, if the Windows domain is configured to use NTLM authentication, we can just pass the hash and authenticate successfully. So to extract NTLM hashes, we can either use mimicards to read the local SAM or extract hashes directly from LSAS memory. So extracting LTM hashes from local SAM, this method will only allow to get hashes from local users on the machine, and no domain users hash will be available. Okay. So privilege debug, you can elevate. Okay. And then extracting NTLM hashes from LSAS memory. This method will let extract any NTLM hashes from local users and any domain user that is recently logged onto the machine. And then we can use the extracted hashes to perform pass the hash attack by using cards to inject an access token to the victim user on a reverse shell. Okay, so notice we use token revert to re-establish our original token privileges, as trying to pass the hash with an elevated token won't work. Okay, so this would be equivalent to using a run as net only, but with a hash instead of a password, and we spawn a new reversal from where we can launch any command as the victim user. Okay, so to receive the reversal, we should run a listener attack box. Now passing the hash using Linux. So if you have access to a Linux box, several tools have built-in support to perform pass the hash using different protocols. For example, connect to RDP using pass the hash, X free RDP, victim IP, domain, then path to pass the hash and tell hash. Connect via PSXX using pass the hash, and then we can connect using WinRM. And the other method for authentication is Kerberos authentication. Okay, so the first user sends his username and the timestamp, which is timestamp request encrypted using a key derived from his password to the key distribution center. Okay, so the KDC creates a ticket granting ticket, also known as TGT, which allows the user to request ticket to access specific servers without passing their credentials to the service themselves. And also a session key is given to the user, which they need to generate the request that follow. So now the TGT is encrypted with Kirby TGT hash, accounts password hash, so the user can't access its content. So it is important to know that the encrypted TGT includes a copy of the session key as a part of its content, and the key distribution center has no need to store the session key as it can recover a copy by decrypting TGT if needed. So when user wants to connect to a service on a network like Share or any database, they will use their TGT to ask the KDC for a ticket granting service, which is also known as TGS. So TGS are tickets that allow connection only to a specific service for which they were created. So in order to obtain a TGS, the user sends his username and timestamp encrypted using the session key, along with the TGT and a service principal name, which indicates the service and server name that is intended to be accessed. And in return, KDC sends TGS and a session service session key, which is needed to authenticate to service that needs to be accessed. And the TGS is also encrypted with service owner hash. And the TGS can be sent to desired service to authenticate and establish a connection. The service will use its configured account password hash to retrieve the TGS and validate the service session key. Another method is pass the ticket. It will be possible to extract Kerberos tickets and session key from LSS memory using minicards. And this process usually requires us to have system privilege for attack machine and can be done as follows. Okay, let's see. Injecting tickets in our own system doesn't require administrator privileges. After this, the tickets will be available for any tool we use for lateral movement. To check if the tickets were correctly injected, we can use klist command. Now another method is overpass the hash or pass the key. This kind of attack is similar to pass the hash but is applied to Kerberos network. Okay, so whenever a user requests a ticket granting ticket, they send a timestamp encrypted with encryption key, which is derived from their password. And the algorithm used to derive this key can be either DES, RC4, AES-128, or AES-256, depending on the installed version of Windows and Kerberos configuration. Okay, so if we have any of these keys, we can ask KDC for a TGT without requiring the actual password. Hence, the name pass the key. Okay, the following commands can be used for obtaining Kerberos encryption key. So if we have RC4 hash, we can run the following command to get a reverse shell via pass the key. Okay, if we have AES-120 hash and the following command for 256 hash. So to receive a reverse shell, we should run a reverse shell on our. So let's go to work. So to begin this exercise, we need to connect this particular machine using SSH. We will be connecting to CRD. copy the password. Okay, so we are in. Now this credential will grant administrative access, okay, allowing us to use mimikast on the authentication material needed to perform any of the techniques. Using our SSL session, use mimikast to extract authentication material and perform pass the hash, pass the ticket, or pass the key against domain user Toby Beck. So once we have command prompt with its credentials loaded, we can use WinRS to connect to a command prompt on THMISS. Okay. Find my cards. Spin tools. Okay, so now let's try to get the keys. But we are interested in keys of Toby Beck. Let's find the username. Toby. Here is Toby Beck. Domain username and we have RC4 keys. AES256 key. Now let's see. So depending on the available keys, we can run the following commands. Okay. So we have RC4 hash also. So let's run RC4 hash. And we will also need to start a reverse shell. So let's edit this command. So our IP is 10.50.77.148 and we need to update the keys. Let's copy the key. Let's see if this works. Yeah, we got the shell Felicia D. Now let's go ahead. So once we have command prompt with this credential loaded, we can use WinRS to connect to a command prompt on THMIS. So since these credentials are already injected in our session as a result of any of the attacks, we can use WinRS without specifying any credentials. Okay. The username or password is incorrect. Let's see again. What was the issue? This again. Let's debug. Okay. 5. Terminal 4, 3, back 2, back 1, and then this is back. So let's try with AES keys. We need to edit the command again. Okay. 10.55 dot, sorry, 50 dot 77.148. Okay, I think I did change the user that time. Toby Beck. T1 underscore Toby. Okay, let's try this again. I think this should work this time. Okay, AES 256 key must be length of 64. Now what? I missed 6. Sorry. I guess it should work this time. Okay, again. Why it is happening? I think this time it worked correctly. Okay, let's try again with RC4. I think I did some syntax error. Maybe here the space. Let's try again. Missing at least one argument. Let's try this again. Okay. Then our IP address 77.148 and then port number. Let's enter the key. We'll copy that again from here only. Okay, perfect. Let's see hope it works this time. Yeah, it worked. Yeah, we have shell. Initiate. Okay, now we can run the WinRS command. Hope it works. Yeah, it worked. So now we can have our flag. Worked. No password needed, but it required more than that. Okay, I accept. Now I'm using user behavior. So under certain circumstances, an attacker can take advantage of actions performed by users to gain further access to machines in the network. While there are many ways this can happen, we'll look at some of the most common ones. So first one is abusing writable shares. So it is common to find network shares that legitimate user to perform day-to-day tasks when checking calculated moments. And if those shares are writable for some reason, attacker can plan specific files to force users into executing any arbitrary payload. So one common scenario is finding a shortcut to script or executable file hosted on a network share. Okay. So the rationale behind this is that the administrator can maintain an executable on a network share and users can execute it without copying or installing the application to each user's machine. So if as attacker we have write permission over such scripts executables, we can have them as backdoor to force user to execute any payload we want. Okay, backdooring the VBS scripts. So for example, if the shared resource is a VBS script, we can put a copy of nc4.exe on the same share and inject the following code in the shared script. So what we'll do, it will copy nc4.exe from the share to the user's workstation in the temp directory and send a reversal back to attacker whenever user opens the shared script. Then similarly backdooring an exe file. The next is RDP hijacking. So when an administrator uses remote desktop to connect to machine and closes the RDP client side instead of logging off, his session will remain open on the server. Okay. So if we have system privileges on Windows Server earlier, we can take over any existing RDP session without requiring a password. So and from there we can run PSXX64. Okay, so to release the existing session or server, we can do the following command: query user. Okay, so let's see what we have to do here. So to complete this exercise, we will need to connect to THMJMP2 using a new set of credentials. Okay, let's get our new set of credentials, and we need to connect to it using RDP. Copy the command. Okay, there the password. Password is password one. Yes. What's next? So we'll work on hijacking an RDP session. And if you are interested in writing backdooring Excel file, you can find some exercises. Just go to the presentation. So follow the instructions to hijack T1 topic back RDP session on THMJMP get flag. So when executing query session, we will receive several username followed by a number. These are just identical copies of the same user and we can hijack any of them. Marked as disconnected. Okay. This is our RDP session. First, search for CMD. Run as administrator. Yes. Okay. We need to go to tools and PS x64.exe. Okay. Okay. cmd.exe. Great. So to release this existing session, you can run the following command: query user. Okay, so we need to hijack a disconnected one. So we were currently connected by RDP using the administrator user. Okay, our session name would be RDP TCP6. We can also say our Luke has left a session. We have opened with an ID 3. Okay. So any session that is state has been left open by user and it isn't used by moment, we can take over active session as well. But the legitimate user will be forced out of the session when we do so. So to connect to a session, we will use tspawn.txt and specify the session ID. We will be taking over and as well as our current session name. Okay, so let's do that. Tspawn. Let's take over ID2. Okay, then this and our current session name, which is RDP TCP hashtag 41. Okay, I forgot the hyphen. THM nice one. Now, port forwarding. Most of the lateral techniques we have presented required specific ports to be available for an attacker. But in real world network administrator may have locked some of these ports for security reasons or have implemented segmentation. So to avoid these restrictions, we can use a technique called port forwarding, which consists of using any compromised host as a jump box to pivot to other hosts. So there are techniques for SSS tunneling. So it already has built-in functionality to do port forwarding through a feature called SSS tunneling. While SSH used to be a protocol associated with Linux system, Windows now ship with OpenSSH clients. Okay, so it can be used in different ways to forward ports through SSH connection, which we will use depending on the situation. So let's assume a scenario where we have gained control over our first PC, known as PC1, and we would like to use it as pivot to access port on another machine to which we can't directly connect. So first we'll start a tunnel from PC1 machine, acting as SSH client, to the attacker's PC, which will act as an SSH server. So why to do so? Because we'll often find an SSH client on Windows machine, but no SSH server will be available most of the time. And since we'll be making connection back to our attacker's machine, we'll want to create a user in it without access to any console for tunneling and set a password to use for creating the tunnel. So SSH remote port forwarding. So for example, if firewall policies blocks the attacker machine from directly connecting to port 3389 server, and if the attacker is previously compromised PC1 and in turn PC1 has access to port 3389 server, then that particular PC1 can be used to pivot to port 3389 using remote port forwarding from its. It allows to take a reachable port from the SSH client and project it into a remote SSH server, which in this case will be attacker's machine. Okay. So this particular command will establish a SSH connection from PC1 to the attacker's IP, which is 111.1.1.1 using a tunnel user. So this particular user isn't allowed to run a shell on attacker's PC, and we need to run the SSH command with the -n switch to prevent the client from requesting. And the R switch is used to request a remote port forward, and the syntax requires us first to indicate the port will be opening at SSH server. Okay, followed by a colon, and then the IP and port of the socket will be forwarded. Remember that port numbers don't need to match, although they do is an example. Okay, so once channel is set and running, we can go to attacker's machine and RDP into the forwarded port to reach the server. Then there is local port forwarding, allow us to pull a port from SSH server into SSH client. Okay, then we have port forwarding with socat, then dynamic port forwarding and socks. Okay, so you can read about that. Dynamic one proxy chains are used. So since we're doing SSH connection from the lab network back to our attacker, back to our machine using tunnel user for this task, they're highly encouraged to use attack box or a VM instead of actual machine. Okay, Instructions have been given on creating user that won't allow running commands or transferring files, so be sure to follow them as provided. It is also recommended to create a strong password for tunnel user and make sure it is unique and discardable password. To complete the exercise, we need to connect to THM using the credential assigned to us from task 1. Okay, these are credential. And if you haven't done so yet, we click on the link with the credentials. Okay, so let's get there. Okay, this was our account. Yeah. Okay. So our first objective will be to connect via RDP to THMICC. If we try to connect directly from our machine, we will find that 3389 has been filtered via firewall. So we will be using SOCAT, which is available here. Okay. Let's go ahead. So we'll forward the RDP port to make it available for THM JMP to connect from our machine. So we can run this command. Okay. Note that we can't use port 3389 for our listeners. It is already being used in THM Jump for its own RDP services. And you are allowed to change listener port 13389 for different port number. Okay. So once the listener has been set up, we will be able to connect to THMIS via RDP from our own machine by pivoting through our cat listener at THM GMP. Okay, so let's try that. Yes. Okay, so we are in. Once connected, you should get a flag from T1 desktop. Okay. THM site beyond site. Let's enter the flag. Okay, so let's move forward. So tunneling complex exploits. So the server is running a vulnerable version of Rejector HFS. The problem we face is that firewall loop restricts access to vulnerable ports so that it can only be viewed from THM JMP2. Furthermore, outward connection from this server are only allowed machine units local network, making it impossible to receive a version directly to our machine. And to make things more worse, the rejected HFS exploit requires an attacker to host an HTTP server to trigger the final payload. But since no outward connections are allowed to our machine, we will need to find a way to host a web server in one of the other machines in the same network. So let's see how this exploit works. First, it will connect to the HFS port. Okay, our port emitters right to trigger a second connection. This second connection will be made against the attacker's machine on the SRV port, where a web server will deliver the final payload. Okay, and then third step, attacker's payload will execute and send back a reversal to the attacker on a listener port. Okay, so let's HFS will be listing on port 80. So we need to tunnel that port back to our own machine through THMJMP2 using remote port forwarding. And since the attack box is port 80 occupied with other service, we'll need to link port 80 on THMDC with some port not currently in use by the attack box, which is port 888. Okay. For Savri port and L port, let's use two random ports at will. Okay, so two random ports are users. So to forward such ports from our attacker machine to jump to, we'll use local port forwarding by adding L. Okay, so this will be the whole command. We need to give our own IP, which is 10 dots, 50 dots, 8. You can change the ports, not an issue. Okay, let's add a tunnel user. SSH command. I wish ports are available. Okay, let's start. Uh, okay, let's try this. Yes. Yes. Thing. Okay, so we need to go to this again. Okay, try that. Run this. I hope network is running fine. Okay, huh? Could not resolve host name. Okay, my VPN is not working. Is working. Everything is working. Okay, I have reset the machine. Let's try again. If this works this time. Most of the time, it happens that I've reached to last flag and then something bad happens. Sir Campbell password. Finally, it's connected. Now let's try with our SSH credentials again. I hope this works this time. 10.50.77.148. Let's see. Okay. Oh, remote port forwarding failed for listener port 888. B. Let's try changing the port, or there must be a problem in command. 8765. Okay, okay. We would need to change here too and set our port to 8765. Let's try again. Okay, payload request received. Try again. Finally, we are in. Let's see. Flag.txt. THM forwarding it all. Damn, I got a lot to edit for this video. But anyhow, I finally finished that. So conclusion. So we have discussed the many ways an attacker can move around the network once they have set a valid credential. Having as many different techniques as possible to perform lateral movement will always be helpful. And should you be interested in more tools and techniques, there are few resources given here. RP word Chisel. Chisel is also one of the famous tool for forwarding. So that's it for today. I will see you in next video. Till then, keep learning.